Hi guys, this is I would like to find out the range of values for which x squared minus plus k minus 4 x minus k minus 7 is greater than 0 for all real values of x. So this actually means that if we are talking about this function to be greater than 0, right, it does not mean that the discriminant is greater than 0. So we have to differentiate between the function being greater than 0 and the discriminant greater than 0. Now if the function is greater than 0, this guy really means that your graph over here, which is your y, okay, is actually above the x-axis for all real values of x. So it actually means that your discriminant is less than 0 and the coefficient of x squared is guaranteed to be positive, which is clearly seen here. Okay, so there are also times where the coefficient x squared is an unknown, maybe unknown constant such as k. So you have to also be careful to pay attention to the coefficient of x squared. Okay, so over here, to find the range of values for which x squared plus k minus 4x minus k minus 7 is greater than 0, what we need to do is we basically need to identify the a, b, and c. Okay, so you can see that a is equals to 1, b is equals to k minus 4, and here c is equals to the negative of k plus 7. Now be careful, a lot of students who actually came forward to ask for consult actually missed out the minus sign. Okay, so you must remember that when we pull out ABC, we are looking at this template, which is ax squared plus bx plus c equals to 0. So looking at the minus sign here, this c will encompass the whole term over here. Now with that, let's form up our inequality. Discriminant b squared minus 4ac less than 0. Now simplify this. I hope you are able to do this by yourself, which I will not go through the nitty-gritty details. This gives you k squared minus 4k minus 12. You have k minus 6k plus 2 less than 0. And this is basically just negative 2k between negative 2 and 6 by drawing the graph. Now take note, when you are drawing this graph is for the discriminant. It is not for the actual graph. Now this graph is for the discriminant, not for the original graph. The original graph in terms of x. Now this graph they are drawing is for k. So this is for the discriminant and the earlier one. So the discriminant can cut. The original one doesn't cut. Okay. So for the next one, okay, I think most of you are actually having some issues with. So a lot of you are actually having some issues with part 2. Now part 2 actually is really nothing much, but just asking you to comment. Now because I think there are 3 marks given, so it's a bit daunting. Okay, so don't worry. Basically, what you did is, because when they ask you to comment, you must have 1 mark for you to actually equate the 2 graphs together. You realize that by doing so, you have actually obtained the same question that you have gotten in part 1. Okay, now because we have actually solved for the discriminant of this equation in part 1, well, for k between minus 2 and 6, you can see that definitely this equation has no solution. This means that the curve will not intersect the line when k is between minus 2 and 6. Now by taking the complement, you can say that if k is less than or equals to minus 2, or k is more than or equals to minus 6, it should be equals to 6, sorry. So this should be equals to 6. Then the line and the curve can intersect once or twice. Okay, basically is I would say if k is equals to minus 2 and 6, right, it will actually intersect once because this is where the discriminant equals to 0. If the k is less than minus 2 or k is more than 6, actually it will intersect twice. Okay, so in any valid format, as long as you comment on the different situations for different values of k, that will allow you to give a good comment. Okay, so not to worry. Alright, so this is just for the question. Okay, thank you.